Hello, everybody. Okay, I believe this is our last live session before TASMO, and this session is very, very important because I'll be going through some challenging questions, topics, as well as giving some very important final reminders. So please do stay till the end, right? Because every pre-exam information is important. Okay, so with that being said, let's wait for around 2 more minutes for more people to join, and then we will start at 5:30 punctually. All right, once again, hello, hello. Okay, we are currently at our last TASMO prep session right before 2025 TASMO. So let me wait for a few moments. Okay, and then we will start at 5:30 p.m. All right, we're waiting for more and more people to come in. Hello, hello. Okay, and then yeah, it's 5:30 now, so let's get started. Okay, hello everybody. This is Teacher Yong Lam again. Right, I believe it's our sixth time meeting for TASMO. Okay, and hopefully by now you have already prepared well for P2 TASMO. Now, if you haven't, it's okay. Right, you still have around 2 weeks of time to complete more practice papers or maybe take a look at our all-in-one guide, right? And we will also be compiling some mistake rescue kits for everyone, right? For those who submit via the link. So if you haven't done the submission links, please make sure to submit via them as well so that we can collect data to curate a better mistake rescue kit for you. Right, as for today, I will be going through, hello, hello, hello. Yeah, we'll be going through a lot of challenging topics, as well as some very important final reminders. So whether you're a student or you're a parent, also please take note and stay towards the end. All right, so without further ado, let's get started with one of the most evil topic ever, right? The first two problems in our challenging topics rescue kit is on calendar problems, and teacher Yonglam would like to remind you about a problem solving trick. Right, so previously in the 20 problems that I have sent in last week, okay, every question has a very important knowledge point or secret technique that everyone should know. So what am I going to share in this calendar problem? Let's read the question. Right, if there are 4 Mondays and 4 Fridays in October, which day of the week will 31st October fall on? Right, so this question isn't asking how many days later, right? What day is 100 days later, etc. It is describing a month to us, right? The number of certain days of the week in a month. And it is asking us about the day of a week for a certain date. So a similar question has appeared in sample paper 4 and 5, I believe, right? And my tip to you is whenever we are describing a month, when the question is describing a month and they ask how many Fridays there are or what is the last day of the month, what is the first day of the month, please remember to draw out the calendar and visualize everything. Right. So how do we draw out the calendar? The first step will be we need to identify what is the month. The month is October. And in that case, can anyone tell me how many days are there in October? How many days are there in October? October has 31 days. Very good, right? October has 31 days, right? So please remember this fact when you fill in the days or draw out the calendar later. Right. So we know that there is going to be 31 days in October, meaning there will be one, there will be one, two, 3, 4 full weeks. Actually, every month will have at least 4 full weeks, right? Because a month has at least 28 days. 28 divided by 7 is 4, remainder 0. So regardless of what month it is, how many days there should be 4 full weeks in total in that month, right? But there might be some extra days after the 4 full weeks, right? Maybe this is a bit messy, so let me clear it and draw it again. Right, so we have 1 full week. Okay, we have 2 full weeks. So you don't need to draw out the 7 days. You can just draw a bar to show that it is 7 full days, 1 full week. Right, we have 4 full weeks. But then after the 4 full weeks, how many extra days are there? Now, 31 divided by 7 is equal to 4 remainder 3. So after the 4 full weeks, there will be 3 extra days. So these 3 extra days are my 29th, 30th, and 31st, right? Because the 4 full weeks already cover your 1 to 28. So 29, 30, 31, they will be the 3 extra days. Now that we already filled up the extra days and the full weeks, right, it's time to assign which day of the week it is, right, at the header section. Right, remember in your calendar, before you even start listing the dates, actually they will show you Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Now we need to arrange where are my Fridays, where are my Monday, Tuesday, up to Sunday, right? How should I fill in the header? So how do we do this? Let's take a look at this question. The hint is there are 4 Mondays and 4 Fridays. So we will need to fill in the days of the week here in the week so that there are 4 Mondays and 4 Fridays. Right, so let's try to list out how a generic week looks like. So we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, right? Supposedly, this is how a week looks like. But I cannot just put them, right, carbon copy onto here, Monday, Tuesday, Wednesday, because I want to make sure there are 4 Mondays and Fridays. And so we need to test out one by one. Can I put the different days at different positions, right? For example, since I know Monday cannot be 5 Mondays, so maybe I'll start putting Monday here, right? The 4th day of the week is Monday. Is it possible? Then you just check one by one. Monday, Tuesday, Wednesday, Thursday, and then I will come back to Friday. Friday is now having 5 of them. So is it possible that Monday is the 4th day of the month? Cannot. Right. So you can test and try one by one, or let me first continue filling it in. Right. In the case that we just assumed, then my 7 days of the week will be arranged like this. And then you notice from Friday to Monday, it is 4 days, right? Friday, Saturday, Sunday, Monday, 4 days consecutively from Friday to Monday. So that means there is only one way to arrange Friday and Monday so that there are 4 Fridays and 4 Mondays respectively. That is if I put my Friday here, right? The 4th day of the week, Friday, then Saturday, then Sunday, then Monday. And then you see just nice, 4 Fridays, 4 Mondays. Okay, so that is how you do this question, right? We try to draw out the calendar, how many full weeks there are, how many extra days are there, and then we try to fill in the headers with the days of the week in the correct order so that it matches the question's description. Okay, so let's continue. Monday, Tuesday, Wednesday, Thursday. Right, and the question is asking 31st October is which day of the week? So you just look at 31st, right, refer up. That is the 3rd extra day and it is a Thursday. So my answer is C. Right, so regardless of what type of variation there might be, but as long as the current calendar problem is asking you to describe a month, or it describes a month for you, right? The first day is not a Friday, the second day is Saturday, something like that. Then draw out the calendar to visualize and fill in the headers with the days of the week. All right, so this is a very important, technique when it comes to calendar problems. Now, with that being said, let's take a look at the next evil topic, which is snail climbs well, right? It appeared in our sample paper 2 and 3. So let's read the question. A squirrel wants to hide 120 acorns in its burrow, right? Who still remembers this snail climbs well, right? You can type 1 in the chat, right? A squirrel wants to hide 120 acorns. Starting from day 1, during the day, it collects 8 acorns and keeps them in the burrow. So plus 8, right? Yay, I get 8 more acorns. However, unfortunately, a naughty crow will steal 2 acorns from the burrow at night. So during the day, plus 8, at night, minus 2. When you see a question that plus and minus repeatedly, then it is a snail climbs well problem. And you need to remember our framework for these sort of problems. Right, but ultimately it is asking on which day will the squirrel be able to reach its goal. It's on day number what? Okay, goal. What goal is it? Right? What does the squirrel want to achieve? Right? The squirrel wants to achieve 120 acorns collected altogether. Right? The squirrel wants to collect 120 acorns. But then, is it true that I can just do 120 divided by 8? Hey, pretty number, 15, day 15. Is it possible? Can I just do that? Cannot, because not only does the squirrel collect acorns during the day, it also loses some acorns at night, right? Because it is stolen by the naughty crow. So we need to find out after one whole day, after each whole day, what is the net gain of acorns? Right, whole day includes a day and night. During the day, I collect 8 acorns. At night, I unfortunately lose 2. So the net gain of acorns after one whole day will be 8 minus 2 equals to 6. Whoops, typo, 6 acorns. Right. So after every day, right, I will have 6 acorns collected net. Oh, does that mean I can just do 120 divided by 6? Haha. Right. No, that is not a thorough consideration, right? You shouldn't just do that because the last day is special. In a snail climbs well problem, we aim to reach our goal of reaching a certain height, right? We want to be tall enough or we want to collect many enough objects. Now, to reach our goal, the last day, we just gain acorns. That's enough. I don't need to be like, oh, I reached 120 already. Okay, let me throw again and then continue the next day. Do I need to, once I reach my goal, do I need to still throw away and then say, it's fine, I'll wait for one more day? Don't need, right? We just reach our goal as soon as possible. So on the last day, there is only gain and I don't lose. So on the last day, the squirrel only needs to gain acorns to reach the goal, right? He doesn't lose any acorns. Then, at most, how many acorns are collected on the last day? On the last day, there is only gain. So I can gain at most 8 acorns, right? 8 acorns. So, in order to reach the last day, collect at most 8, and then, okay, I call it a day. That means it must have collected at least 120 minus 8 equals to 112 acorns before the last day, right? My CO kids should remember this. This is what I call my sprint zone, right? Just enough so that on the last day, I can just collect at most 8 and call it a day, reach my goal. So how many acorns does the squirrel need to collect before the last day? That will be 112 acorns. So now we just need to find how many whole days are needed to reach 112 acorns at least, right? How many whole days do I need to enter my sprint zone to reach 112 acorns? Now remember, by number of whole days, I mean after 1 day and 1 night. This one package. How many days and nights do I need at least to reach 112 acorns? We know that every whole day, I will gain 6 acorns at the end. So I just need to do 112 divided by 6 to try out. Hey, but you realize that it's 18 remainder 4. So while you see a remainder, right, we should mention what does 18 mean? What does 4 mean? Right? Whenever you do division with remainder in a word problem, ask yourself, what does the quotient mean? What does the remainder mean? In this case, 18 means I will need 18 whole days. But after the 18 whole days, I am still lacking 4. Remainder 4 means I still need to collect 4 extra acorns before I can reach 112. That is why 18 whole days is not enough to reach 112 acorns. we need 18 plus 1 equals to 19 days. In particular, 19 whole days. Right, I will need 19 whole days to reach my sprint zone, to reach 112 acorns, so that on the next day, only gaining acorns is enough for me to reach the goal. Now that I need 19 whole days to reach 112 acorns at least, does that mean my final answer is 19 as well? What do you think? Is my final answer 19? 19 whole days, right? No, what? 19 whole days is just to reach 112 acorns, right? To reach 120, which is my final goal, I will need 19 plus 1 equals to 20 whole days. That means on day 20, I am able to reach the goal of 120 acorns. Right. So in this question, snail climbs well, please remember that the last day is special because you only go up, you only gain, right? You never lose anything. All right. And now we have gone through the word problem part of the challenging problems. Okay, so now let's take a look at logical reasoning. Now, of course, it's not just calculation and word problems, right? There are also other sort of puzzles, if you may, right, in Olympiad math, right? So let's take a look at this logical reasoning problem. The conversation of a group of 4 is as follows. A said there is at least one of us that speaks the truth. B said there are at least 2 of us speaking the truth. C said at least one of us is lying. D said at least 2 of us is lying. The question is asking who is lying. So we imply that there is one person who told a lie because who is lying. So whenever we are seeing a logical reasoning asking about truths and lies, right, we try to search for contradictions and agreements. Are there 2 people who are saying the complete opposite thing? Or are there 2 people saying the completely same thing? They might help us to figure out, right, who is telling truth, who is telling lie. But other than that, right, we can also assume the statements one by one, right? Assume A is lying, assume B is lying, assume C is lying, and assume D is lying. Right? Then we just try to see whether it works or not. Now here, actually, I don't need assumption method because by who is lying, we already can lock down that the lie is only told by one person. So there is only one liar. And in this case, D said there are at least 2 of us lying. So obviously, D is telling a lie, right? But I want to take this chance to tell you also, how do you turn a lie into a truth? And how do you use assumption method in doing that, right? So basically, let's try to assume that A is the liar. Okay. If A is the liar, that means B, C, D, they are all telling the truth. Okay, they are all telling the truth. And then what do you need to do now? You just need to keep the other statements, while for A, you need to switch it to its opposite to turn lies into truth. Usually how we do it is, if the statement doesn't have a not, we will add a not. There is not at least one of us that speaks the truth. Okay, so by A's meaning, A said that there is one or more truths, right? That is the meaning of at least one of us speaking the truth. So there is 1 or 2 or more truths. And since it is a lie, we need to add a not in front of it. So it's not one truth and also not more truths than that. Actually think, if there's not one or if there's not more, then how many truths are there? Then according to A's statement, we switch it. We can switch it into there are 0 truths. Because we don't want 1, we don't want more than 1. So the only number of truths that is available left will be 0 truths. Right. So to convert a truth into a lie or a lie into the truth, if you see not, remove the not. If there is no not, you have to add a not. And think about it. Not one truth, not more than one truth. That means how many truths are available. Let's use another example. Assume D is the liar Now, if D is the liar, let's say what D said. D said there are at least two of us lying, meaning there are two lies or there are more lies. But since D is the liar, we need to turn it into truth. To turn it into truth, if there's no not, we add a not in front. There are not two or more lies. Now think about it. I cannot have two lies. I cannot have more lies. So how many lies could there be according to D's statement? Cannot two, cannot more than two, so it could only be less than two, right? So it must be less than two, which means one or zero lies, right? So it could be one, it could be zero, we don't know, right? But ultimately, we want to make sure, we converted the truth to the lie or the lie to the truth correctly while we preserve the other statements. We don't touch the others. If you assume that it's only one liar, the lie we change to the truth already, the others we don't touch. We will just read them as they are. All right. Just that in this question, you technically don't need assumption method, but good for me to mention to you here. All right. So with that, let's take a look at the next part. Another logical reasoning with some geometry involved, right? It's called dice problems. Okay. So here, a standard die is a cube with 6 faces, each having 1 to 6 dots on it. And on top of that, hopefully you still remember, opposite faces in a die should add up to what? What is the sum of the dots, right, on the opposite faces of the die? Left face and right face, or top face and bottom face. They will add up to 7, right? For my fellow CO kids, you will learn it in this week's lesson, right? For those who haven't, it's okay, right? Here's just a little bonus fact, right? And here, when you see some faces are glued together to make a solid, please pay attention to the conditions in the touching faces. Sometimes they might say, okay, the faces that are glued together have the same number of dots. If two faces are glued together, they have the same number of dots. Or if the faces are glued together, they add up to a certain number, add up to 7, add up to 8, etc. So you need to pay extra attention to the question. What is the condition in the touching faces? And also look at the picture below. Where are the touching faces? So we already see that there is 7 dice here. There are 1, 2, 3, 4, 5, 6. Where is the 7th die? Where is the 7th die? Why is there only 6 dice here? That's because if you notice in the middle, there is a hidden die. Right, let me draw it out. In the middle, it is a hidden die. And all of its 6 faces are touching with the other die. Right? Each of its face is pasted with another die's space. Each of the hidden die's faces is painted to another die's faces. Now, in that case, how many faces are pasted? The 6 faces of the hidden die are all pasted or are all glued. Okay, so now my question is, how many dots are on the surface of the solid? Which means we also could find how many dots are not on the surface of the solid. They are pasted. Now you look at the center die and you notice that since the 6 faces of the hidden die at the center are all glued, that means none of its faces will be exposed. That means the middle die, all of its faces are hidden. I don't need to count their dots. How many dots does the hidden die have? It has 1 plus 2 plus 3 plus 4 plus 5 plus 6 equals to 21 dots on the hidden die that has been hidden and not exposed. We don't want to count them, right, when we are counting the number of dots on the surface. Now, we have excluded the hidden die. Does that mean that only 6 faces we need to exclude? What do you think? Now, the 21 dots are the hidden die. The die in the middle, the one that teacher Yongnam drew just now, right, it has been completely hidden because it is pasted by the other or pasted with the other dice. But remember, teacher Yongran has emphasized this previously. When you have two hips touching each other, how many faces are actually glued together? Is it only one face? No, it is not, right? Because you see, like my face, right? This face is touching, this face is also touching. So when I glue them together, the two faces are all hidden. They are just facing each other and not exposed. So that means there are also 1 plus 2 plus 3 plus 4 plus 5 plus 6 equals to 21 dots on other dice that are hidden. Right, so previously the middle die is hidden, all 21 dots are hidden, but they are hidden because some other faces are touching it, and the other faces touching it will not be exposed, will not be on the surface as well. 1 touch with 1, 2 touch with 2, 3 touch with 3, so on and so forth. So for every one face on the hidden die, there will be another same face from another die that is glued onto. Right. So that's why there are two sets of 21 that are hidden, and we don't need to count them. Now, these are the only hidden dots because you see there's only the middle die, and each die has outside has one more face sticking to it. So all we need to do is to find out the total number of dots minus the dots that are hidden to get how many dots are on the surface. Now we have 7 standard dies, so the total number of dots before I glue them is simply 21 times 7, right? Because it's 1, 2, 3, 4, 5, 6. Every one of them is the same. Then I need to minus 21 minus 21, right? Because of the two sets of 21 that are hidden, right? Due to the pasting. Then, upon further calculation, you will notice that 105 dots are found on the surface of the solid. All right? Someone said, huh? Okay, it's because there are two sets of 21. One comes from the middle die, one comes from the other dies that are pasting with the hidden die. So the total is 105 dots that are on the surface, right? We take total number of dots before we glue any dies together, then minus away the touching dots. All right. With that, hopefully it's clear now. Okay, if you have any questions, don't just give me a question mark. Please type it on the chat. Nothing else, then please do not spam the chat box. Okay, keep it civilized. Now, let's take a look at counting through the shapes, right? Honestly, whenever you see this problem, by now, you should know what are the common tips and tricks, right? So when it comes to squares, right, it is the most standard shape that you could see. So my advice to you would be to count the squares by their size and orientation. Size means whether they are small or big, 1 unit, 2 unit, 3 units. Or orientation, whether they are upright or they are tilted. So let's count together. How many 1 unit squares are there that are upright? Right, so let's see. Very obvious. 1, 2, 3, 4, 5, 6. So there are 6 upright 1 unit squares. But on top of that, are there any bigger upright squares? For example, are there any 2 unit squares that are upright? I can't hear you. You can type in the chat. Okay, so you see there's one more here. Wow, there's a bigger upright triangle, 2 unit by 2 unit. So there is one such square with a larger size that is upright. Okay, so up till now, the upright squares, these are all that we found. But don't forget, there could be some slanted squares as well. But they are squares. Their orientation are just different, but they are still squares. So we need to count them as well. How many slanted squares are there? Let's again start from the smallest possible size here. Right, do you see any slanted squares in this picture? How many slanted squares that are the smallest are there? How many? Right, do you even know what's the smallest slanted square like? It looks like this. Right, you see, this is a slanted square that is the smallest, 1 unit big. And there are 1, 2, 3, 4, 5, and 6, right? 6 squares that are 1 unit big. Okay, stop spamming the chat. Okay, please listen carefully. All right, so these are the slanted 1 unit squares. And there are also bigger ones, right? There is a bigger 2-unit slanted square as you see over here. Let me draw it a bit clearly. Right, as you see over here, this is a 2-unit slanted square. It is bigger. There is one such square. Okay, so altogether, how many squares can you see in the figure? There are no bigger ones. Okay, these are the biggest you can go. So the total number of squares will be 6 plus 1 plus 6 plus 1. That is equal to 14 squares overall. Right. So when it comes to counting squares, make sure you count the size and count the orientation. Right. Go in order small to big, upright, then tilted. All right. And then now with that, let's take a look at another counting 2D shapes question. Right. How many triangles are there in the figure below? Now, when you see these type of triangles, some of you might think, hey, teacher Yonglam, I just label part by part, right? 1, 2, 3, 4, 5, 6, 7, 8. And then I see which parts can be combined together to form a triangle. Now, that is definitely a useful strategy, right? But then in this picture, the triangles are special. They look special because, as you can see, let me just take like one part of it, maybe something like this. You see this triangle has a side with a lot of intersecting points, right? It has a lot of points on the base of the triangle. On the base of the triangle, there are a lot of points. And then on every point, they shoot up to the same peak. Right? From every point, you can draw a line or draw a side to the top of the triangle, to the opposite vertex. They all lead to the same peak, right? Which is why these are what I call triangles with the same base. And then we can use the shooting method to attempt this problem. Right? The key in shooting method is to realize that, right, there are, for example, 4 points over here, A, B, C, D. However, I choose my 2 points and I shoot them up, I am able to form a triangle with my top vertex. For example, if I choose A and B, then I shoot up, shoot up. I realize that I can form a triangle. Or I can pick further points, right? What if B and D, right? Shoot up, shoot up. Again, you realize they form a triangle. So choosing any 2 points at the base, shooting them up to the peak, they will form a new triangle. So I only use the shooting method and I can solve this question fast. In this case, we just need to count, right? For example, starting with point A can pair up with how many points to form new pairs? A and B, 3. A and B, 1 pair. A and C, 1 pair. A and D, 1 pair. So 3 pairs with A. Then let's look at B. B has already formed with A, so that's an old pair. But then how many new pairs can B form? Now B can form with C, and B can also form with D, right? So in that case, B and, hold on, B and C, B and D. So there are 2 new pairs. C can form a new pair with D, so 1 pair, and D is by itself. There is no other points to form new pairs. So all I need to do is 3 plus 2 plus 1 plus 0, right? Because we just need to see how many choices of 2 points on the same base are there. So 3 plus 2 plus 1 plus 0, we have 6 ways to form our triangles. Now, using this idea, let's take a look at the bigger figure here. There are how many triangles in the figure below? Now, this question is a bit more difficult because there are 2 layers, right? The first layer is like this. The first layer is on top. It is a shorter layer, smaller layer. But again, you see that at the horizontal base over here, there are a lot of lattice points, a lot of intersection points that shoots up to the same peak. So we just need to count how many pairs can we make from selecting these points. So you see, the leftmost point can pair up with 4 other points. So 4, 3, 2, 1, 0. So for the top layer, we can form 4 plus 3 plus 2 plus 1 plus 0 equals to 10 triangles with just the top layer. But these are the top layers, so they are the smaller triangles. We can also form some bigger, taller triangles by not only considering the top layer, but also considering the bottom layer as well. Let me change my color a bit, right? You see, if I include the bottom layer together with the top layer, then we can see that there are a lot of points on the base and they all shoot up to the same peak on top. So they are same base. They are some triangles with the same base at the bottom layer as well. Then all I need to do is to use the shooting method again, right? As usual, the leftmost point can form 1, 2, 3, 4. 4 more pairs. Okay, and then 3 pairs for the second point towards the right. 2, 1, 0. Again, the bottommost triangles, I can form 4 plus 3 plus 2 plus 1 plus 0 equals to 10 triangles. Basically, I'm just choosing how many ways are there to select 2 out of these many points at the same base of the triangle. So there are smaller triangles on the top, 10 of them, bigger triangles at the bottom, 10 of them. So the total number of triangles, 10 plus 10 equals 20. There are 20 triangles in the figure below. All right, so that is for this shooting method problem. Whenever you see triangles with the same base, right, from a line, a lot of points, they shoot to the same peak, the same opposite point, then you can use shooting method to count the triangles. Okay. With that, are there any questions so far? Okay, if there's no question, then let's move on to, hey, our favorite, right? You see this slide for a lot of times now. Now I have put another such question, right, in the challenging topic recap. But this question has a catch because it is asking, right, if I have some treasure chests and some keys and they are jumbled up, at most how many tries are needed to open each chest, to open each chest. I am not identifying, I am not realizing, I am not discovering, I am not matching the key to the chest. I am trying to open the chest. So for example, let's look at the first chest. At most, how many times do I need to open this chest? How many tries of the keys? So maybe I can try the first key. First key cannot. Oh, fail. Second key cannot. Oh, fail. At this point, do I need to try the third key? In this case, do I need to try the third key? Well, actually, you need to, right? Because we need to open this chest, right? Very good. We need to open this chest. Since we need to open this chest, just identifying the key is not enough. We need to use the correct key to open the chest, right? To put it into the keyhole, open the chest. So I will need to try one more time with the third confirm correct key to open the chest. So there are 3 tries that I need at most to open this chest. Okay, what about the second chest? Now that I already identified this key is for the first chest, I don't need to try it anymore. Right? It's just one of the other 2 keys. So I will need to try 1 and 2, 2 tries to open the second chest. Right? Because trying one time is not enough. If the one time you are unlucky, you pick the wrong key again, then there is one more key remaining and you need to open the chest with the key. So you need one more try. Likewise, to open the last chest, we will just need one more key. So all I need to do, or one more try using the remaining key. To open the last chest, we need one more try with the remaining key. So all I need to do, 3 plus 1 plus 2 equals 6. 6 tries are needed. And the moral of the story, right? If I want to open the chest, then the number of tries I need for every chest is equal to the number of keys required or available. If there are 3 keys currently available to me, I need to try at most 3 times. If there are 100 keys available for me, unlucky teacher Yong Lam will need to try out all 100 keys before he could open the chest using the last one. Right? In the most unlucky scenario, I would need to try out every key. Okay? Right, and yes, 3 plus 2 plus 1 is 6. Very good. So now, here we have Jane, right, who was doing the live stream just now for P1, right? Jane has 11 boxes with 11 accompanying keys. Each box can only be opened by its accompanying key, so it's again a one-to-one matching. If the 11 keys have been mixed up, find the maximum number of attempts Jane must make before she can open all the boxes. Now, again, this is a bit different from your sample paper 1 and 4's similar question. because we want to open the boxes. We don't only want to identify which box belongs to which key belongs to which box. We want to open the box. Okay, in that case, then what I need to do is, for the first chest, I need to try out all the keys, right? If I'm unlucky, I will need to try all the way until the last key before I can open the box. So I will need 11 tries for the first box. Then how many tries for the second box? Is it still 11? The next one, is it 11 plus 11? No, right. We have one less key to try because just now we opened the previous chest with one of the keys already. So I don't need to use that key again. So I just need to try 10 more times. So 11 plus 10 plus 9, 8, 7, 6, 5, 4, 3, 2, 1. Right, so these are all the tries I needed from the first chest to the last chest. And they add up to 66. So the maximum number of attempts means tries. The maximum number of tries that Jane needs to make to open all the boxes is 66 tries or 66 attempts. Right. So in this question, it is different from previously because we want to really open the box with the keys. Right. Just identifying is not enough. All right, so that is for addition and multiplication principle. Remember to read the question carefully. Does it ask you to discover, to realize, to identify? Or does it require you to really open up every chest, right? Because depending on what the question means, what the question asks, your answer will be slightly different. The number that you start adding from will be slightly different. So pay attention to that. All right, now with that, we enter number theory. Actually, I think I didn't go through many number theory questions in the paper run through, but it's okay, right? We can just go through them now. Question 1. How many even numbers are there among the whole numbers from 30 to 200? Now, what is even number? This is a multiples and common multiples type of problem. Even number basically means it has to be a multiple of 2. Right. So how many multiples of 2 are there among the whole numbers from 30 to 200? So some of you might just simply do 200 minus 30 and then divide by 2, right? Now that is actually not correct, right? So how do we do this question? Now, remember, the numbers, we need to exclude something, right? We need to use division to do this question, but it's not a simple one-step or two-step division. So here's the framework. Please pay attention how to do it. Step 1. We want to figure out how many even numbers are there from 1 to 200. That will be 200 divided by 2 equals 100 even numbers. Everybody knows this step, right? From 1 to 200, I have 100 even numbers. Definitely very intuitive. But then, do we really want all the even numbers from 1 to 200? Do we want all of them? No, because we want from 30 to 200. From 30 to 200. So we want to include 30. Including 30 all the way up to 200. How many whole numbers are there? So does that mean I want to minus away from 1 to 30? Does that mean I need to minus away from 1 to 30? What do you think? No, right? Very good job. I see someone in the chat saying that. No, you don't want to exclude 30 because we want from 30 to 200. This includes 30 and it also includes 200. Now, there could be a similar ambiguous wording called between 30 and 200. Right? From my understanding, if you see the word between, that it is strictly in between the endpoints. I do not include 30. I do not include 200. That is if I say between. But then here it says from, so I need to include 30. I want to include 30, so of course I don't want to minus away 30, the multiple 30. So I will only exclude, right? The second step is to find out the numbers that you exclude. As stated in the tip, to exclude, we only exclude the numbers up to start minus 1. The starting point here is 30, so I only exclude up to 29. Okay, and then how many even numbers are there from 1 to 29? So how many multiples of 2 are there from 1 to 29? You just need to do 29 divided by 2 equals 14 remainder 1. And then you just take 14. So there are 14 even numbers that we need to exclude. 14 even numbers to exclude. The remainder 1 means we are on the way. We are not finding the 15th, the next multiple of 2 yet. We are halfway there. We are in progress. So we want to count from 30 to 200. That's why I do not exclude 30. I only exclude up to 29. And I found that I need to exclude 14 even numbers. So altogether, from 30 to 200, how many even numbers are there? Now, using this 1 to 200, there are 100 even numbers, but I excluded the ones before 30. I only exclude the ones up to 29. So I minus away. How many even numbers did we exclude? 14. 14, not 29, 14. There are 14 even numbers that I need to exclude. So I will do 100 minus 14, and therefore there are 86 even numbers. There are 86 even numbers from 30 to 200. Okay, so now in this question, the SOP, the standard procedure to solving it is just find the total, find out who to exclude, and then minus. And be careful, the decision of where to exclude until depends on the wording of the question. The question says from 30, so I want to keep 30 and remove everything before that. No, it's not 85, right? Some people might think, hey, it is right because 100 minus 15, right? 30 divided by 2 is 15. But remember, I want to keep 30. All right, so that is a tip that I want to share, right, with this multiples problem. And now let's move on to the next part, which is on divisibility. Right, I remember last week we talked about the divisibility of 3. So can you remind everyone in the chat what determines if a number is divisible by 3 or not? What condition is the divisibility of 3 representing? Do I check the last digit? What do I check? Do I check the last digit? No, right? You don't check the last digit. You should check the digit sum. The number will be a multiple of 3 if its digit sum is a multiple of 3. So you don't need to do long division, right? You just need to check the digit sum. And some of you already gave me an answer. But remember, I want possible values of m. So there may not be one possible value. There could be 2, there could be 3, there could be 4. Right, and also you need to pay attention. If m is not at the highest digit, m could be 0. Right, in some other questions, perhaps in sample paper 5, we saw that. Okay, so in this case, 5015m is divisible by 3. So let's check their digit sum. 5 plus 0 plus 1 plus 5 plus m. Simplify the numbers that we know. That will be equal to 11 plus m. We want it to be divisible by 3. Okay, so 11 plus m. We already have 11. How many more do I need to add to make it divisible by 3? Right, so you could try, I know 11 plus 1 equals 12, possible. 11 plus 4 equals 15, multiple of 3 as well, possible. 11 plus 7 equals 18, possible as well. Right, 11 plus 10 equals to 21, possible. Haha. Right, but don't forget, m is a digit. So it cannot be 10, right? 10 is not a digit. Digits can only be 0 to 9. So we only have 3 cases, right? The 3 possible values of m, 1, 4, 7. Right? Remember, there could be multiple possible values. So please make sure you consider everything thoroughly. All right. And yeah, with that, that is the divisibility of 3. What about the divisibility of 4? Right, James is copying down a number, but he erased the 10th digit, so 6 something 4. He knows that this number is divisible by 4. What are the possible values for the 10th digit? Right? Do I still look at the digit sum? do I still look at the digit sum to check if it's divisible by 4? If it's divisible by 4 this time, we do not check the digit sum. We check the last two digits. Everything in front, I don't need to care, right? 6 something 4. I don't even need to care about 6. All I need to do is to check something 4 is a multiple of 4. As long as that is the case, then it's okay. So what are the possible digits? Some people might have said, teacher, I know. Can 0 be counted? Of course can, right? Although you might think, 0, 4, this is very weird. But when it's 0, 4, we just treat it as 4. After all, 0 is actually not the highest digit or highest place in the 3-digit number given. It's 600 and something. So it could be 604. So the possible values for the tens digit start from 0. Any others? 0, 4 is a multiple of 4, right? Which I write it as 4. What else? What else? What 4? 24, very good. 44, yes. 64 and 84. You realize that all these numbers that I've listed here are multiples of 4. So the possible values for the tens digit is 0, 2, 4, 6, 8. Aha. Another key point. Some of you might be very careless, right? So please read the question carefully. Is it asking for possible values of the digit, or is it asking for the possible values of the whole number, right? Please read the question carefully, identify what it is really asking, and give the correct answer. If it's asking for the whole number, don't just give one digit. This applies to all the other problems you see, right? For example, class A and class B. Is it asking for class A or is it asking for class B? I don't know, right? So you need to check properly. Okay? And with that, so that is for divisibility of 4. Now let's move on for divisibility of 9. Okay? Divisibility of 9. Do I check the last digit or check the digit sum? Do I check the last digit or do I check the digit sum? Right. So here, the divisibility of 9, you just make sure the digit sum is a multiple of 9. Similar to 3, right? The digit sum is what we use to check for the multiples of 9. But here, it gives you a very big number. The 7-digit number 2018ABC is divisible by 9. So of course, I want to make sure 2 plus 0 plus 1 plus 8 plus A plus B plus C is a multiple of 9. Now, don't need to do too much. You first simplify all the numbers that we know. 11 plus A plus B plus C is a multiple of 9. So all I need to do is to first find out what are the possible values of A plus B plus C. Okay, now remember A, B, C are all digits. So that means they could be 0 to 9. They could be 0 to 9. Now, in that case, what are the possible values of A plus B plus C to make it a multiple of 9? Think about it. And also, then you read the question, what is the largest possible value of A times B times C? A? It's not asking for A plus B plus C. Again, read the question carefully. We are finding the product of the 3 digits. Okay? Now, in that case, sometimes you might need to make some educated guesses, right? Make some common sense guesses. You see, we want the largest possible value of A times B times C. Do you think this happens when my A plus B plus C is large or when my A plus B plus C is small? Will a larger sum give me a larger product or a smaller sum give me a larger product? Of course, I want A plus B plus C to be right. A plus B plus C has to be as large as possible. It has to be as large as possible. So let's try to list what are the possible values of A plus B plus C. I know the After 11, the next multiple, 11 plus 7 equals 18. Possible, right? Okay, let's go further. 11 plus 16 equals to 27. Possible? 11 plus 25 equals to 36. Possible. Okay. 11 plus 34 equals 45. Possible. Or is it? No, right? Because remember, we have three one-digit numbers here. A, B, C are all digits. So they could be 0 to the largest possible value of A plus B plus C. A plus B plus C is going to be at most 9 plus 9 plus 9, which is equal to 27. So A plus B plus C, even in the largest possible case, it could only be 27. So definitely it could never be 34. Cannot. Right? That means the largest possible value of A plus B plus C is 25. Okay, so A plus B plus C is equal to 25. We want it to be as large as possible, so it's 25. But hey, I want to find what is A times B times C's largest possible value. So we still have one more step. We need to find out what are the possible values of A, B, and C that leads to the largest product. So in that case, we need to do something called number splitting. Right. Is there any way to split 25 as the sum of three one-digit numbers so that the sum is 25? Three one-digit numbers add up to 25. Any consideration? Of course, since it's very large, maybe, okay, maybe it's 9, not 8, 8, 6, no, 9, 9, 7, right? If you want A and B to be as large as possible, 9, 9, then C is at least 7. So that's one way of forming a sum of 25. So I could do 9 times 9 times 7. And what's the answer? Right, quick, calculate. What is 9 times 9 times 7? 9 times 9 times 7 is 567. Okay, is that the answer? Is that the answer? Not necessarily, right? You need to first consider if you have split 25 into three one-digit numbers in every possible way. Now, let me tell you, 997 is not the only possible way to split 25. It's okay, you can leave early, right? The payback is still here. You can actually also do 9 times 8 times 8 as well, right? You see, 9 plus 8 plus 8 is also 25. If I donate a value 1 from B to C or from A to C, then I get 988, 2 8s and 1 9. And the multiplication result is 576. And that's larger, right? So that is the result that I want, 576. And after careful consideration, you notice that the only two ways to split 27 as the sum of three one-digit number is either 997 and 988. So all you need to do is to just consider each case. Yeah, undoubtedly, this is pretty challenging, right? It has divisibility, it has number splitting in it, right? And one final thing, does it matter if A is 9 or B is 9 or C is 9, right? It could be 799 or 997 or 979. It could be, right? But the order doesn't matter here because to decide the divisibility of 9, I just need to look at the digit sum. And also, I want to find the largest possible product. Multiplying numbers and adding numbers, the order of adding and multiplying doesn't matter. So as long as I could single out, right, what are the combination of the digits, there are two such combinations that I can test one by one to see who gives me a larger possible value. All right, so that is it for the questions part of today's live stream, right? So we have gone through a lot of challenging problems. Hopefully, I have shared some useful tips and tricks with you. Okay, with that, okay, kids, if you are still on the live stream, right? If you're still watching and your parents are around, please call them around, right? Because the upcoming segment is about some important reminders and information about the competition, right? So please invite your parents to listen along, right? Some things that you should know, some things that parents should know, some things that everyone should know. The following things are important, right? So please take note. 好的，酷。如果接下来要讲的是比赛资讯的哈，如果家长有在场的话，也欢迎一起聆听。对，有一些重要资讯的。Okay, so first of all, these are the most important information, right? Our competition date and time. So the date for the competition is on 13 September 2025. It's a Saturday. During that week, there is no Think Academy long-term courses, right? So just attend the competition. The time for the competition is 9 a.m. to 10:30 a.m. You will be sitting a 90-minute competition paper. Okay, and although the competition starts at 9 a.m., the reporting time is 8:30 a.m., right? Please report early for registration, right? In case there could be some queues, in case there could be some hiccups in transport, in traffic, etc. Arrive earlier, right? Our reporting time is 8:30 a.m., right? So just to familiarize with the environment and do your registration in time. The location could be either Novena, Tai Seng, Buona Vista, or Marine Parade, depending on what you indicated for your registration. So please check with your teacher, okay, or check with me, right, whether your registered venue is correct or not, in case you have forgotten, right? And very, very important, please arrive on time. If you arrive 15 minutes late, you are not allowed entry into the competition anymore, right? So please allocate enough time for reporting, for registration, right? To find your exam seat, perhaps search around to see where's the washroom, okay, and familiarize yourself with the environment. And especially because our exam is a morning exam, and please plan your journey ahead, right? I've just seen news, right? Our Circle Line MRT is going to start later on weekends, right? From September to December. In particular, right? According to the news, right? The train service will resume on 9 a.m., right? On weekends, including Saturday and Sunday. And our exam is a morning exam. It starts at 9 a.m., right? So it is possible that you might not be able to take the Circle Line MRT to reach our venue on time, right? Particularly Tai Seng, right? I think Tai Seng, Buona Vista maybe, right? These are near your Circle Line stations. So if you are planning to take the Circle Line MRT, please check with the MRT attendant to see if there is train service at your planned travel time. Otherwise, please consider alternative travel plans, right? Maybe taking a cab or taking bus, right, would help. I think there should be buses that travel along the stations, right? Please check with the MRT staff. Okay, Circle Line, please take note. Okay, plan your journey ahead. This is very important. Okay, and now for what to bring during the competition, right? We will have an email entry sent to you around a week before TASMO, right? So you will receive an email like this that confirms your location, right? The competition time, date, your personal particulars, etc. What you need to do is to print out this email entry proof and bring it to the registration during the competition day itself. Along with that, please remember to bring a photo ID or student card or passport or anything that can verify your identity, right, for your child so that they could be admitted into the exam venue. And as usual, since this is a competition, definitely you will need some stationaries. Please remember to bring a 2B pencil, perhaps a ruler, perhaps some erasers. And please bring some spare stationaries. Don't just bring one pencil. Okay, bring several pencils, right? Maybe one or two erasers, right? Just that you have enough for standby. Right, and don't forget to bring your water bottle and jacket in case you need to drink water or in case the venue feels cold. Okay, now this email entry proof is important not only because it allows your child to enter the exam venue, right, to register successfully, but also because there will be this thing called the index number, right, which will be very useful for the answer sheet in TASMO. Now, I'm not sure if you have seen our answer sheet before. It's in the WeChat collection as well as the Google Drive for WhatsApp users. Okay, but in this answer sheet, we will need to fill in the index number. So you will need to refer to the email entry proof. Each child will have a unique index number to be filled into here. Right, and speaking of which, let me just go through some of the key details on how to use the answer sheet. Right, so you will receive this write your name and your school name, right? So maybe you can write your name here, Yong Lam, right? For example, write your full name lah, okay? Yong Lam Chao, for example. And your school name, right? Not Think Academy, but your actual school name. And then use your 2B pencil to shade the correct grade level, right? If it's P2, shade P2. Remember to shade fully, right? Don't shade partially. Then for your index number, you will need to write down the digits on top, right? If it's 1, 2, 3, 3, 2, 1, you just write 1, 2, 3, 3, 2, 1. And also shade the corresponding circles with the digits 1, 2, 3, 3, 2, 1. Shade each circle fully, right? Don't shade partially. Okay, and also use pencils with graphite with ink that is dark enough, right? Don't use light pencils. Okay. As for answering the questions itself, for the first 15 questions, it's going to be multiple choice. So A, B, C, D, E, choose your choice and shade the answer circle completely. Again, don't just anyhow scribble. Draw and shade a complete circle. For the short answer question, write your answer clearly within the box, right? You do not need to make it into 4-digit format. If your answer is 1, 2, 3, just keep it as 1, 2, 3, right? It's more lenient than TASMO. Okay, 1, 2, 3 is enough. All right. And also, we will have 50 multiple choice questions and 10 short answer questions overall in the exam, right? The first 10 questions are worth 3 marks each. Middle 10, 4 marks each. Final 5 very difficult, very challenging questions, 6 marks each. Now, if you answered any questions wrongly or if you have any unanswered questions, not to worry because no points will be deducted even if you answered them wrongly. So if you feel like you want to take a gamble, go ahead, right? Maybe you are lucky. Don't worry, there are no points deducted for wrong answers or unanswered questions. All right, so with that, that is all I would like to share about this exam, right? The very important reminders. Most importantly is to plan your journey ahead, right? Check with the MRT staff to see how you would like to travel to our exam centers. Okay, and with that, that is the end for today's live stream as well as all of our online live prep activities, right? Thank you so much. I believe that everyone has worked hard up to this point. There are 2 more weeks left, so I wish you all the best in the exam, right? May the God of luck be by your side. With that, that's the end of today. Thank you so much. Goodbye. All right, goodbye, everybody. If you have any questions, feel free to just type in the chat as well. Okay, and yeah, anything you can just type in the chat or mention it in our group. It's okay. All right, thank you so much. Goodbye. You're welcome.